For today's demo, I'm going to demonstrate how we can accelerate route patching using Ansible Lightspeed together with Ansible Automation Platform. I'll start in VS Code where Ansible Lightspeed operates as an extension. What this gives us is AI-assisted playbook authoring, helping generate structured, best practice Ansible content directly where developers already work. So under the hood, this can use IBM Watson Xcode Assistant with the Granite model, or organizations can configure their preferred model providers such as Gemini or OpenAI. And the key point is this accelerates authoring. It doesn't replace validation or governance. So once this playbook is generated, I'll I'll show what that looks like within GitHub primarily because of version control. Then I'll jump into Ansible Automation Platform using a job template to securely execute the patch workflow against a RHEL system with full auditability, RBAC, and repeatability. So jumping into VS Code, as we can see here, the Ansible extension, what you primarily do in VS Code, right? You go to extensions, search up Ansible, and it should be the first one. Once you have this installed, you should actually see this Ansible icon. Click on that, and once you click on that, Ansible Lightspeed tab should appear. Of course, Ansible development tools also, but for today, we won't be focusing on that portion. I'm already logged in, so from here, we can just click generate a playbook. We should see here is the playbook generation tab. And as simple as this, right? For today's use case, we'll just be patching a RHEL system. So we can type that into the text editor or the text box. So patching a RHEL system. And all we have to do is just click analyze. Waiting for that to kind of just load out. And from here, we're just reviewing what we just put into the text box, patch the system. And the neat thing is that if you want to add a bit more to just the playbook that's going to be generated, like rebooting the system or another task within this human readable file, uh, we can do that right here. So for now, we'll just keep it as patch the system. Continue, and as we can see, it generated these few lines within our YAML file or within our playbook. So from here, we'll just click on Open Editor, and I'll just explain what most of this means. At the top, we have the three hyphens just to declare that this is a YAML file. We have the name of the playbook. This is a sample playbook to patch a RHEL system. And here we have our host. This says RHEL, but you can pretty much put what you like to depending on how you have your inventory organized. And kind of flipping between this playbook that was just generated and our sample inventory. Here I have RHEL, but in the use case that I have within or within the playbook that I have within GitHub, I have something else. But the whole idea here is that you name the group of what you like to use for your RHEL systems, potentially Ubuntu, maybe Windows, within that inventory file, just to kind of organize them better and identify what belongs to what. So our group here is RHEL. For this example, we have rel01.example.com. This is our fully qualified host name, or you can or domain name, or you can actually have just an IP address, whichever makes sense or whatever works for you guys. And flipping back to the playbook that was just generated, as we can see, we're using that specific host group. Uh, if you would like to, let's just say, use it for all the hosts in here, you can just put all. But then if you do this, you'll just have to change up this playbook a bit so it could work for both Linux distributions and of course Windows. So going back to just utilizing RHEL, and you see this neat thing right here. The neat thing about Ansible Lightspeed is that it can actually generate the next line, right? So it'll kind of just think of, hey, this is what you might type after based on Ansible best practices. Typically for uh, automating against RHEL hosts, you would have become yes after. And the thing is that I didn't even have to actually type that out, right? I could have just went back, go here, tab, and then it'll just type it out for me. And all this is just privilege, right? Or sudo. So you'll just be running this task with sudo if you like to. If this task doesn't need sudo or advanced privileges, you won't need become yes within that playbook. And then here we actually have the task itself. The name of the task being pass the system, like we saw earlier. And this extra line item here, wondering what that is, right? So this you can think of as the Ansible collection. This already comes with Ansible, and it's utilizing the built-in module that comes within the Ansible collection. The neat thing is that we can see this last portion, right? What this is a parameter that you pass within that module. Uh, Package in this case means you can use this against RHEL or even Ubuntu, basically RPM or even Debian-based distributions without having to change um, what this means at the end, right? Kind of just a universal parameter. Or you could just change this specifically to DNF for RPM-based distributions or APT for Debian-based distributions. So just utilizing DNF in this case, since it is a RHEL distribution or RHEL Linux distribution that we're automating against, name, and then the asterisk here. All this really means is that we're updating all the packages that are within this RHEL system. And for state, we're just making sure that the desired state is latest, right? So when we shoot off this playbook to our server, this is going to be the latest defined state of our system. So from here, we'll actually just jump into the GitHub repository just to quickly show what that looks like. Now we're in our GitHub repository where we have both those resources, our inventory and our playbook. Here, we have a similar playbook, not exactly the same one that we generated with Ansible Lightspeed. Only a few differences here are the host name and that I added something at the end called register DNF update result, but at its core, it's pretty much the same playbook. And then here showing what that inventory looks like. We have localhost at the top. Neat thing is that you can actually orchestrate jobs for other services utilizing this group here called localhost, and then calling Ansible connection local at the end of that so that the job actually runs against the controller itself rather than against a specific server like a certain RHEL server that you have that you're managing or a Windows server that you're managing. And the neat thing, even though we're not covering that within this demo, you can automate against Windows servers and have that same or that IP address within the same inventory. Of course, this utilizes other protocols. For Linux specifically, it's SSH, and for Windows, it's WinRM. This is the overview. We won't be focusing too much on this portion. We'll be jumping to automation controller where we define our automation straight into templates, and then we'll just go find that template resource that we created with both our playbook and the inventory that was shown. Here we can see it's called rel patch. Jump into that. And I'll just cover a bit of what this means in terms of the details page. Here we have the name of the template itself, and the template you could just think of it as this has all the resources you need to be able to run that job against those specific servers, right? So for rel, you have here we have the inventory that we created, the inventory resource coming from our GitHub repository, and then the project. You could think of a project as Ansible Automation Platform or the Automation Controller, just pointing to your GitHub repository, right, and pulling all those resources from there. So all the resources from that specific repository is a project. Uh, Extra component is, of course, the credentials to be able to access that server, which we already have within our Ansible Automation Platform environment as a credential. So JH rel server, and the JH is just my initials. You don't really have to put that unless you guys want to, right? From here, we don't really need any other option enabled. As you can see with an edit template, same thing here that's being covered with various other options. Here, we don't have privilege escalation enabled just because we have become Yes, within the playbook itself. If you didn't have that already in the playbook, you can just click privilege escalation within templates. So we'll cancel this and we'll jump into launching the template. Launch template, and this should probably take a few seconds at the most, probably 8 seconds, since there doesn't really need to be a change on this host that I have, since it should be all up to date in terms of packages and in terms of patching also. Here we see that it gathered the facts, connected to the host with no issue, applied all available system updates using DNF, since we are automating against a RHEL system. And then from here we see that uh, there was no changes again, because uh, this system is already patched and up to date. So that's all for this specific demo. Hope you guys enjoyed it.